Thank you very much. Does this work? The audio, okay, it works. Oh, right. Thanks for the nice welcome, and thanks for the opportunity to be here in person again and speak. This is fantastic. I really enjoyed it. So, let's move on. So, as already mentioned, SYNC is our acronym for Samba-in-Kubernetes. And today I want to give an update about the projects. And as has been mentioned, let me see, here, this is a presentation prepared by me and my colleague John Mulligan together. Unfortunately, he cannot be here today, he couldn't travel, but he has pre-recorded 2 demos which I'm going to play during the presentation. So he has his share in the slide material and also in the demos. It's always good to pre-record demos to avoid the hassle of failures during the live demo. But this time it was the only way of having John here, at least virtually. So I want to start today's presentation, other than usual, by just telling you a little bit of a story, instead of overwhelming you with a lot of technical slide content right at the beginning. So the story I'm going to tell you is the story of SYNC. This all got started in the year of 2020. So early that year, when we were all still with Red Hat. All of Red Hat was laser focused on the hybrid cloud offering Kubernetes and OpenShift, Red Hat's enterprise Kubernetes distribution. And in the storage team, we had just successfully brought software-defined storage solutions to OpenShift itself. First with Gluster, and the products were called Container Native Storage, or CNS, or OpenShift Container Storage. And then later we used Ceph as the storage backend for our OpenShift-based storage offerings. And that was called ODF, or OpenShift Data Foundation. I won't be referring much to product terms in this presentation at all. And as a disclaimer, this is not a company product presentation. It is whenever I'm expressing opinions or views, they are personal, my own or John's views, and I'm only referring to upstream technology efforts here in this. So it's all about open source and upstream around Samba and Kubernetes for what it's worth. So in that year, in Red Hat, we were in general and in the storage engineering department focused on the Kubernetes container-based solutions. Note that this was less than 1 year after IBM had actually acquired Red Hat. And at that time, Red Hat was still acting with a large amount of autonomy. And you will have noticed on the slides that, on the opening slide, that where previously we had Red Hat, now there's IBM. So I'm going to refer to that a little later. Let me continue my little story. So, while we did have quite some success with bringing first Gluster and then Ceph into Kubernetes-based products. With success, I mean we had released products and we had acquired, or we had found some customers that would like to use them in their data center or cloud deployments. So, but I was somewhat missing my old storage play with Samba, which brought me into the whole software engineering business. And I had been looking for quite some time for ways to get Samba back into the picture of that storage software we were building. And almost out of nothing, 2 possible use cases for Samba had offered themselves to me. The first one was, it's all about Kubernetes-based solutions here. The first use case was people were running virtual machines inside Kubernetes, essentially running the KVM processes inside containers and managing the virtual machines with the same tools that I use to manage the container applications in Kubernetes. The project upstream called KubeVirt, and Red Hat was building that into products based on OpenShift. And obviously, if you're serious about running virtual machine environments, many users will want to run Windows as guests. And if you want to provide storage not only as a backend for the VM images, but also for consumption in the VM guests, then you will want some file storage to share with the guests. And if the guests are Windows, well, Windows is pretty opinionated about how it would like to access storage over the network. It likes to use its favorite file storage protocol over the network, which is called SMB. And obviously, here comes Samba to help. The second use case that offered itself was that of mixed Kubernetes clusters that were arising. So Kubernetes clusters traditionally had only Linux as worker nodes. Worker nodes are the nodes in a Kubernetes cluster that run the containers themselves. And in a mixed cluster, Windows nodes were added as worker nodes, also with the capability of running containers. And we had built our storage software into OpenShift Kubernetes so that the containers could use persistent storage on our cluster or Ceph storage there, without specific file protocols, but just for storing data persistently from the container applications. And if in a mixed cluster, a container running on a Windows worker node would want to store something on a persistent volume, they would need to access it somehow over the network. There are conceptually a couple of different possible approaches. One would be to use native clients on the Windows nodes to access the Ceph or cluster server. But the preferred way over the network would again be file protocol. So accessing a Ceph or cluster volume, whatever it is, over the network, quite naturally would be over SMB with Samba. So that's the second use case. And I had these ideas and visions for quite some time and had internally tried to convince product teams and upper management of those ideas and try to excite them for this, without a lot of success so far. But I thought, instead of writing a lot of design documents or documents and slide presentations to share with the decision makers, I thought that code and working prototypes are much better. So I started to work in early 2020 still on prototype implementations of a Samba container and an operator to manage Samba resources, manage Samba shares as objects in Kubernetes. So luckily that worked, and I was stemming from my experience building operators for our storage products previously. And by the time of sambaXP 2020 in springtime, those projects had progressed enough for me to dare and present these new projects to the Samba community at the conference, which I did in the still virtual conference. Remember 2020, the pandemic was in full swing and we couldn't meet in person, so I gave a virtual presentation introducing the projects. Let me just look at my cheat sheet a little bit. Right. So even internally, I managed to muster some interest for these. And so later in 2020, John Mulligan got interested. He was a colleague working on the OpenShift Data Foundation project or products with me. So he got interested and started to contribute to those, first to the operator, then the container. And he also created the Samba CC project, which is a configuration front end for Samba, which we then used as an alternate entry point for the container images to make it easier to bring up Samba in containers. And together we decided that we wanted to put these projects that we had now, this ecosystem of projects, under a better umbrella, and created the Sync GitHub organization, moved all our projects there so to give them one common home. So up to that point, those projects had all lived under personal accounts in GitHub. But from then on, they had a real home so that we could form some kind of a community there. So that was basically toward the end of 2020. In 2021, let's see, we had additional contributors joining from inside our organization. So first, Niels de Vos joined and contributed to the operator and container. Niels was originally primarily a developer of Gluster and NFS, and in the container world he was one of our main CSI driver developers for Ceph. And some people might know Niels as the organizer of the software-defined storage dev room at FOSDEM. He usually does that every year. And he not only contributed to the existing project, but he also contributed a new prototype implementation of a provisioning Samba CSI driver, so that you can go to Kubernetes and just say, give me a SMB front-ended share, please. So that is something that would be really needed if you want to transparently use Samba shares in VMs or on Windows worker nodes. And at sambaXP 2021 was the first time when John and I gave a joint presentation, still virtual over Zoom, updating about the progress of these sync projects. A little later, we had first external contributions to the repositories. So when I'm saying contributions here, I usually mean either in the form of GitHub issues or comments there, or maybe pull requests and patches contributed to the projects. So either of that. And later that same year, so later in 2021, Günther, Sachin and Anoop joined the efforts. So Anoop is probably known to most, at least virtually, as a member of the Samba team. Also in our team. He was originally working on Samba for Gluster in Red Hat, and he has been joining these in samba-in-kubernetes efforts. And Sachin is probably known as a frequent attendee of sambaXP. He has previously worked on the kernel sys client. He was for some time a kernel sys client maintainer in Red Hat and joined the storage group several years ago. And all these nice guys have contributed to these efforts and formed what we now call the sync team. And then by the end of 2021, an event happened that kicked me off the rails, or literally off my feet. And I could not continue my work on these projects for a long time. But I am all the more excited to be able to be here today and present to all of you the latest and greatest of the sync project's progress. A year ago, I wouldn't have thought this would be possible today, but anyway, it's really great to be here. So let me continue the story, giving you the timeline of the sync project. So what happened in 2022? So at sambaXP 2022, we were continuing the newly established tradition of giving updates about these projects. And John was the one giving the presentation alone this time because I was just unavailable. And he had been driving the projects mostly in my absence. So a little after that conference, we cut the first release of our projects, a version 0.2, basically of all these projects. Samba-container, samba-operator, samba-cc, all of them got a version 0.2 a few months after sambaXP 2022. And even later that year, we had some other developer of our team joining the effort. Sharon from Tel Aviv joined us. He's also been in the container storage development team before. And so from his experience, we could really benefit from his skill sets. And he was adding valuable contributions to the operator and container and samba-cc as well. So by the end of 2022, I was rehabilitated enough to start contributing again to the projects, which was something that filled me with great joy at the time, because it came somewhat unexpected when I tried it and actually worked, and I could first of all review other people's patches and bring them in and resume my own contributions in the form of patches, etc. Let me see. Now that's toward the end of 2022. So 2023 started. And early that year, the entire Red Hat storage team, product team, transitioned to IBM. So this is the reason why we are appearing now with IBM instead of Red Hat. But still, Samba team, of course, proudly where it applies. So for Anoop and myself, this still applies, and of course Günther and others. But Anoop unfortunately cannot be here today either. He had problems getting his visa, which is in India always a high bureaucratic obstacle to take. So, but I think Anoop's later presentation has been pre-recorded and will be played back. Let me see. So now, under the IBM umbrella, we are continuing our efforts on software-defined storage development in and outside of Kubernetes. And we have also been continuing the sync efforts, even though these projects have not yet, at least I would like to say, made it into any products officially. So we are still working on it in the upstream entirely. It's nothing we're doing is officially product-driven, but of course done with the hope and anticipation of possibly being added to container storage products at some point. So it's almost it. So, and in early 2023, still something very exciting happened. David Mulder of SUSE and the Samba team started to contribute to our projects. Is David here? Hi, David. So David added, I will go into a little more details later. So it was really exciting for us to get serious, expression of serious interest in the products. So David contributed to samba-cc and samba-container, adding the capability of building those container images with OpenSUSE as a base image. And I'm really excited to say that, best I know, samba-cc has been added to OpenSUSE factory at some point, and SUSE has started making Samba container images available in SUSE's own registry. That was really exciting for the whole project team. So that is more of external to the Red Hat/IBM sync team contributions, which is always great for a project to attract more external contributors. That was a big milestone for us. So, and with that, my little story is already over. And as mentioned in the beginning, I'm super excited and happy to be here today, something I didn't expect many months ago. So, and I'm ready to present to you the latest and greatest of sync updates, and to investigate the question of, despite its name, is it still afloat or has it sunk for good? Let's see. So here I have one slide summarizing my little story. This is what I meant when I said I didn't want to overwhelm you with too much textual or pictorial content right at the beginning. So this is just a recap of the small history of the Samba-in-Kubernetes projects. So with that, I want to go into and answer the question, what has happened in these projects since last year's sambaXP in 2022? So give you some project update highlights. So there are a couple of main themes here. So first of all, we have been trying to mature those projects. We were trying to build a community, attracting external contributions, and we were trying to give regular project update reports to the Samba technical mailing list for some time at least. That has been established. But this habit at some point died out a little bit. John started it. I think Anoop sent an update or two as well. And then at some point it just stopped, which is something we might revive at some point soon. So we have implemented code quality and test automation improvements in the repositories. We have implemented a couple of new features, and we got rid of some technical debt. And we created a first release, as I mentioned before. Let me see what comes now. So some more details about the general aspect of attracting external contributors. As I mentioned, it was around December 2022 we had first external contributions to operator and container in the form of issues raised and fixes proposed as patches that were accepted. In January 2023, David contributes to samba-cc, and samba-cc gets added to the OpenSUSE factory release. And it was in April, I think, if I get it right, that the OpenSUSE-based container builds were made possible, and you can find, even by searching it on the internet, OpenSUSE published samba-container images on registry.opensuse.org. I think I have not provided links. It's not mine to do, but this is a great thing. Thank you so much. This is exciting for our little projects here. So, a fair number of issues, bug reports, and feature requests have been filed by people from outside the immediate team. That was perfect. A way of building a community, I think. So, and don't be afraid, I'm not going to talk to you with a story for another half an hour or so. It's just a little bit looking at, like, in this presentation, I'm trying to find an answer to the question, is it still afloat, or does it still float? It looks pretty much floating and not sunken, right? So I think the previous slide with the community building and maturing the projects was a little bit of a promising start. And so this is a very optimistic picture, I think, which reflects many of the aspects that have happened. So let's continue with the project update highlights. And now I'm going to concentrate on the different repositories. The previous slide were general highlights for update for the project. So this one is for samba-container specifically. And this has already been mentioned. So explicit choices of Fedora and CentOS as a base image for building the containers have been added, inspired by the OpenSUSE work that David contributed. So previously, before the OpenSUSE builds were added, Fedora was the only and implicit choice of building containers. And now we can explicitly choose Fedora and CentOS stream by using a makefile variable, OS name equals something. So, and the previous default of Fedora base as 35 and 36 initially has now been gone to 37 and newer releases of Fedora as a default base image. So we have added a new image, the toolbox image. So the previous images are still in existence. So we have the Samba server image, which is basically running the file server SMBD. We have a Samba AD server image, which is running the Active Directory server. We have a client image, which contains the client tool, Samba client and net and other utility tools, SMB control. And the toolbox image is very similar to the client image. It is actually based on the client image and installs a couple of additional tools that an administrator might want to have available for administering the Samba server. So we have implemented automation improvements and test and CI improvements. For instance, we added the Mergify bot to our GitHub project, which is very, very convenient. So if you're going the full mile with using the GitHub or similar platforms for maintaining your code, it's very convenient, because Mergify you can configure and tell it which conditions have to be met for a proposed patch to be merged fully automatically. For instance, we have implemented rules, okay, a complete explicit list of automated checks have to pass successfully. And then we require a certain number of approving reviews by team members. And we have implemented one more rule, which is similar but not identical to what the Samba team is doing for upstream. So in Samba team, we have it so that when the author of a patch is a Samba team member, just a single review by a second Samba team member should be sufficient, because the sign-off by the author would count as a review. For external contributions in Samba upstream, we do require 2 reviews by team members by default. And what we've implemented here is a timeout basically. So if the author is a team member, then and a single approving review by a second team member has been given, the patch will not be merged directly, but only after a, I don't know, 2-week period or something has expired, this will be merged, even though a second review might not have happened. So Mergify is another upstream open source project. So that it's a bot that can be installed in GitHub account, and it is. So if there are patches, if there are issues, you can actually try and fix Mergify yourself. That's the good one. Yay, it's open source. And it's powerful and flexible enough to be adjusted to many different situations and needs. So this has made our work a lot easier in getting patches merged. And we have added git-lint for commit message checking. So we know that many projects, including the Samba projects, have their standards and requirements for how commit messages should be formatted and what content they should have. So git-lint and another project is called commit-lint are two projects that can be used for local and CI level checking of commit message in a patch series that is proposed for merging. And this has successfully been established in the samba-container repository. And it is very helpful. So it's good that the first line of defense, which is the CI system, is now already complaining when these standards have not been met. Otherwise, it's pretty difficult it always is the burden on the reviewer to kind of say, hey, look, your commits are not according to the contributing guides. But in our case now, the GitHub CI system already complains if it's not the case. And you can actually check your local branch by just doing make check git-lint or something like this. So we have a local target as well. It's quite useful and quite convenient. So great addition to the whole, making the process a more seamless and lightweight. We have added a release in June 2022. Version 0.2. I already mentioned the 0.2. It's the version we put to all our projects. So the samba-container release was done in June. So it's not very long after the sambaXP conference. And it's work in progress currently. It's not fully merged. It's not merged yet, but it's under review. Is a procedure to build on ARM platform. So currently it's all x86 architecture, only our containers. But we are adding ARM architecture as well. So next update project is samba-cc, so the container configuration tool. So also here we had some code quality improvement. For instance, Python type annotations were added to the code base. The build script now supports different base distros like CentOS, Fedora, etc. And I guess OpenSUSE. So we have the configuration file, which is a JSON. So samba-cc takes an input configuration file, which is its own JSON file, and basically creates samba smb.conf configurations out of it. And we have added config validation with JSON schemas. So that's already good for making sure it doesn't regress and the functionality stays the same. And the file format is actually valid. And we've added more config file formats with TOML and YAML. YAML is certainly known to everybody, and TOML is another markup like or smb.conf ini style like file format that is prominently used in the Python testing frameworks. So also here we have added Mergify and git-lint checking. The release 0.2 was done on May 25th, 2022, even closer to sambaXP. And we have continuously built and published RPMs of samba-cc in a Copper repository recently. So Copper is a ad hoc way of doing Fedora and CentOS RPM packages and publishing them as YAM repos. So this has been established relatively recently. But those samba-cc packages can now be downloaded from a YAM repo in Copper, and they are used in the container images. Okay, let's move on. Final project to provide updates for is the samba-operator itself. So same as before, Mergify and Gitlint edit, super helpful. Version 0.2 was done on June 8th and not June 2nd, so just a few days after the release of the Samba container. We have added group chairs and cluster chair support with CTDB. So what are group chairs? Previously, the samba-operator only created chairs that one SMBD server instance would serve out a single share only. But we all know that a single Samba server can serve multiple SMB shares. So group shares are grouping multiple shares to be served out by a single SMB daemon container. So that is a new capability that the samba-cc config format can now support as well. And it's an operator feature though. And cluster chat with CTDB is again something that how the operator sets up the Samba containers to serve out in a clustered mode. So yes, we are using CTDB here. A question could have been, are you using Kubernetes clustering capabilities? Kubernetes is a cluster after all, so there are some clustering capabilities, but we didn't dig very deep and we decided to go with CTDB because it's what Samba kind of requires for clustering at this stage. And there's, I think, a lot of interesting potential for discussion with what Ralph has investigated on. So we have added documentation for our custom resources, or CRs. And if you remember from previous year's presentations, the custom resources are essentially the way of extending Kubernetes type system. So our main custom resource is an SMB share. And not the server or service is not the main type, but the main type is the share in our way. So they have been officially documented. No. Okay, there's more. I think I should probably skip forward. I have to tell you about some additional developments that we have added. I might keep that for later. Let me do the demos first. So I'm going to get back to this later. So now time for some demos. Okay, we have prepared 2 demos actually. And so one focus here is to run the container, but not with Kubernetes, but we can run containers just on a Linux host with purely Podman and systemd or so for orchestration. So which is what the first demo does. It shows setting up a file server with Podman and systemd and using a new Podman feature called Quadlet.
In this demo, I'll show how the Samba container can be used to export existing storage with only a small amount of setup. I'll be using Podman and systemd to run the container. As a bonus, we'll be exporting CephFS using the Samba VFS module. I already have a 3-node Ceph cluster running. I also created a standalone node to run Samba. First, I need some information from my Ceph cluster. I already have a minimal configuration file, but I need an authentication token to access the file system. I also want to create a CephFS subvolume. It's a convenient way to organize the data in the file system, and it lets me set the directory's initial permissions. The path is not deterministic, so I need to ask Ceph to tell me what the path is. Next, I need a place to keep my Ceph config files on my Samba node. I'll copy my minimal ceph.conf file contents. Here, I'll copy my auth token into a Ceph keyring file. Now, to copy the Ceph files into the etc Ceph directory. My next task is to set up our Samba server container. I'll start by creating the config file. I'm writing this config file in the TOML format. I think TOML is both easy to read and write. You can read more about the config file format and its parameters at the sambaCC GitHub page. Every config file requires at least one top-level configuration. We'll call ours sambaXP. We'll define one share under it called sambaXP, and a global section called default. We'll define our share, sambaXP, with an options subparameter, and these options are just passed along to the Samba configuration. Since we're setting up Ceph, we need a VFS objects, and I'll copy and paste the path that we got earlier from Ceph. The remaining configuration parameters configure the Ceph VFS module. And then finally, because I don't want to keep making so many typos, I'll copy and paste the rest of our share configuration. We'll define a global section called default to match the configuration above. I'll just copy and paste this in. The final section of the configuration file will be defining our users. These users are set up automatically by sambaCC when the container starts. I gave it a moment of thought, but then decided I would copy and paste the parameters. The next task is to define a configuration file that will automatically start the container on boot. We could skip this step for our demo, but I wanted to show one way that this would be possible. This uses the recent Podman feature called Quadlet. Quadlet generates services from container-specific service definitions. We're running Podman, so we're going to need to define what container image will be used. We're going to use our project's Samba server image, and we're going to use the nightly tag. This allows us to take Samba's master branch, which has some fixes for Ceph. We're going to use host networking because this is the only container the system's going to run, and host networking greatly simplifies things. We need to expose a few volumes to the system. That includes configuration and a location for Samba to store its state files. Also, we need to expose the Ceph directory. sambaCC, in addition to being controlled by its configuration file, is controlled by a few environment variables. We're going to tell sambaCC exactly where to look for its config file, and this has to match the directory we're mapping in. And we're going to define an environment variable to tell sambaCC its specific configuration instance. Finally, we tell Podman exactly what command to run when the container starts. We'll be treating this as an all-in-one container, so we ask sambaCC to perform a few setup steps to configure the environment before launching SMBD. Let's create the directories that we referenced in the previous file. And then we'll copy in the configuration file. We also need to copy the container unit file into a location where Quadlet will pick it up. To ensure our service starts up nice and quick, we're going to proactively pull our container image. We'll reload systemd so it picks up the new config. And now we can start our Samba server container service. As intended, the service is up and running. Let's do a quick test on the local system. Looks like we can access the share. Can we write a file? Success! Now that our smoke test is complete, let's jump on to the Windows VM that's been patiently waiting for me. I need a moment to remember the VM's IP address. But once we enter that, I'll choose our second user, put in the password, and okay, I'll never say I don't make typos. In fact, let's just typo everything from here on out. Well, I hope you enjoyed the demo. I hope that it demonstrated that Samba containers can be used with a minimal amount of orchestration and still provide useful file sharing services. Here are a few links for some of the resources that we used in preparing this demo. Thank you very much for watching.
And the second demo is running Docker Compose for orchestration. So we prefer to use those open source tools like Podman instead of Docker. But Docker Compose has been quite popular recently, and we have been using it for the second demo. The main point of the second demo is to demonstrate to run both an Active Directory domain controller with Samba and a Samba file server on the same physical or virtual node with the help of containers. To reuse the same compute resources to serve out both, and the actual the separation, the isolation happens at the container level, which is really useful for this.
In this demo, I want to show how containers provide resource isolation by running a samba-AD domain controller and file server on the same host. We'll be using the very popular Docker Compose for minimal orchestration. For variety, I'm running the demo on Debian Bookworm. The only VM here is the single Debian node. The containers are what will make it possible to run both services on a single host. We'll be using 2 configuration files in this demo. The files are long enough that I don't want to type them in for this demo. We'll make sure that they're available online so that you can read them at your leisure. The first file is the samba-cc configuration file. This one is in the YAML format. The first section, configs, contains 2 subsections. This means the single configuration file can create 2 different, distinct Samba container instances. We have one share, named share, for the file server. It has some options, which are equivalent to the options in smb.conf. Additionally, we have a permission section, which tells samba-cc to initialize a directory with a given set of basic Unix permissions. Within globals, we have 2 subsections. One disables printing, the other defines the properties that the file server will need to be a member of the domain. The domain settings section defines some properties that the ADDC will use when it's initializing. Beneath that, the domain groups and domain users section define initial groups and users that the ADDC will use to automatically populate the domain. Docker Compose uses a YAML-based configuration file to determine what containers will be brought up. Under the services section, we define 5 different containers to create. The first service definition, DC, is used to create our ADDC instance. This is a privileged container, and it is assigned a specific static IP address. The remaining 4 service definitions are for the file server. The first 2 are considered init containers. These containers are expected to exit. The remaining 2 are for running WinBind and SMBD. Because of the close relationship between SMBD and WinBind, we need the containers to share certain namespaces. The file server containers are also given a static IP for simplicity and consistency with the AD container. The remaining sections of the file configure volumes and networking. Moving over to our test node, let's make sure we copied our configuration files. And we'll need a directory to store those files so that the container can read them. I like to proactively pull my containers to make sure the host already has the needed images. We'll need a samba-AD server image, as well as the Samba server image, or the file server. Because my local network is not set up for easy DNS delegation, I'm going to cheat a little and prepare a custom resolve.conf so that my file server can find the ADDC. Now I'll just move those files into place. Because a domain controller is not a microservice web app, it has some additional networking needs. Specifically, it wants to know its own IP address, and clients must be able to reach it at that address. I found that Docker's IPVLAN driver worked best and was easiest to set up on my network. We'll make sure to link to the docs for that Docker network driver at the end of the presentation. It's time to bring up our containers. The startup process pauses at the join container because we didn't provide it with any files it could use to perform an automatic join. That's not a problem because we can switch to another terminal and interactively join the file server container to the domain. Going back to our compose command, we can see that the long-running containers have started. Checking Docker directly looks okay. One last thing before we test our client system. I always have issues remembering IP addresses, so let's add the IP of our file server to our ADDC DNS. Proceeding on to a Windows client system, I'll log in as a local user. Get access to the networking properties. Set the ADDC as a custom DNS server. And now join the Windows system to the domain we just set up on our container host. Let's speed through the reboot process. We can now log in as a domain user. If I remember to type the password. Looking good so far? And we have immediate access to our file server as well. I hope that you enjoyed seeing me run both a Samba DC and file server on one node with just our container images, Docker Compose, and 2.5 configuration files. There's so much more I wanted to share in this demo but could not because of time. If you'd like to know more, please contact us through our GitHub projects. They're linked here with some of the other projects we used in this video.
And there are links here. Let me point you to it. So we have already had some created links to those recordings and created discussions in our GitHub organization for Samba Container. So John has added those discussions with link to the videos there. So the links should be publicly accessible. The main point is that because John cannot be here today to possibly answer questions, if there are any questions, please navigate to samba-container and discussion number 129 or 130 and ask questions that I think it's a little early for John right now. It's round about between 7 and 8 in the morning. So as soon as he's at the computer, he might be available to answer questions. So this is our substitute for a real upstream mailing list or chat room for this. So use the discussions on GitHub. But John is also usually having an eye on Samba technical mailing list and chat on metrics also. So he will try and help with a little latency to answer questions if there are any. Okay, let me now. In the slides that will be published soon, there are more links and references collected in this page. So if I have like 2 minutes or so, just for the outlook, what's coming next. So we have a couple of short-term and long-term plans. In the next 3 or so months, we want to complete the implementation of ARM-based builds for the samba-operator and samba-container. We want to create a next release, probably version 0.3. Continue improving our technical and process documentation. We want to add continuous testing on OpenShift. I didn't even mention that we had started testing on OpenShift, which was, it's not automatic because while OpenShift is a distribution of Kubernetes, it's not vanilla Kubernetes. So even the tooling is a little different and some APIs are changed. So something that runs on Kubernetes does not necessarily run out of the box on OpenShift. So we have this effort started, want to continue it. We want to add custom Samba configuration options to samba-operator. So longer term plans, the rest of this year and beyond. We want to take more feedback from the community and help implementing fixes and new features on operator and container, etc. So we would like to do what David did for OpenSUSE and include samba-cc directly in some distros, maybe Fedora and CentOS where we have a certain amount of influence still for a start. So in addition to just doing a next release, we would like to establish the habit of regular releases, like time-based releases, for instance, every 3 or 6 months or so. At this stage, it's a wish, it's an intention. I don't guarantee we will make it, but we'll try. So we should resume the regular update reports to Samba Technical in mail form, if that's of interest. We want to take advantage of additional Samba features, for instance, the offline domain join, which was originally created by Günther, I think triggered by the discussions about these things. And we often planned but never added it to the capabilities of operator and Samba container directly, but this is on the to-do list. So we would like to have a configurable location for the XAttr for anti-ACLs with the TDB-ACL module, because the current XAttr location requires elevated privileges in the system, which makes it difficult in container environments. So we would like to use the sme.conf API, maybe via some Python wrapper in the samba-cc tool, which is written in ripe Python. So this is also more of an idea than a concrete plan. So and specifically, John is going to explore further opportunities for container platform support and integrations, meaning John was the one who went beyond Kubernetes and went off to Podman, systemd or Docker Compose and other solutions. So we don't want to be just a single Kubernetes-focused project, as I hopefully have demonstrated to some extent in the previous. And so widen the base of platform integration testing in SIT. So SIT is the slide I skipped. It stands for Samba Integration Tests. I'm resisting the urge to go back to the slides and go over them because time is out. So just in words, really quickly, in previous sambaXPs in 2020 and 2021, we have presented a framework where we were building nightly RPMs from Samba master and unreleased branches and setting up a cluster back in the day with Gluster and Samba CDDB cluster on top of it, running a subset of SMB torture test suite against it for a nightly and regular testing of Samba latest code. So we have moved these these functionalities under the sync umbrella into new repositories there, and this is where we are building our nightly Samba builds, RPMs, and they are built into the containers now. So we want to widen that and test more with it. But it has already been largely successful. We have found and fixed a regression in Samba provisioning in Samba tool. All of that came out of this testing of nightly master builds. So there are many more ideas which you can find in the projects and GitHub on the repositories. So finally, what I haven't really addressed yet is the continued benefits of sync for the Samba community. Of course, initially these projects were created with the idea in mind to have Samba benefit from these additional use cases and so on. So that testing with unreleased Samba versions and builds has already proven extremely useful, I think. So the nightly and Samba integration testing frameworks exercising Samba master and release branches on a daily basis. As I mentioned, found and fixed in AD provisioning regression, merge request number 2991. Found and fixed by John himself, actually. And I think Andrew reviewed and merged it eventually. So he was aware and he was expressing his excitement that we did testing with master builds automatically. And this, if we continue this, it can only be beneficial for the community. So just look at the checklist we had in 2021. We had suggested possible benefits for the ecosystem, which was, let me see. And I think most of that has turned out to be true. So with those containers and declarative configuration, it's even easier to set up a Samba file server and maybe even an AD server than it is without containers. So that ease of use and deployment is. Yes.
We have to come to that.
Oh yes.
It will be a 15-minute over.
Right. Okay. I'm reminded that we have actually run out of time.